All right, so this is part two, continued. And just a reminder, from at the very end of the last video, we found out the mass of this hydrate, the copper 2 sulfate pentahydrate. We found the mass by subtracting the mass of the evaporating dish from the evaporating dish plus hydrate, and we got 7.53 grams. Right? So we used the same formula, plugged it in, said, okay, if we do this, we have 2.72 grams of water in our sample. So I heated it. The water came off, right? Water is evaporated, the color changed of the salt, and this is the predicted mass. So we subtracted 2.72 from the 49.59, and here is, so 46.87 is the predicted mass, and I'll just show you this. And there we go, 46.88. So 0.01 grams off. That is pretty good. Yeah, I broke the evaporating dish. I should probably have left it on the clay triangle a little bit longer. Right? I should probably left it on there a little longer. Anyway, I did want to show you what happens. This is some copper 2 sulfate anhydrous that has been cooled down. So I'm just going to drop water on it, and am I crazy? So you saw the like, it sounded like it sizzled, which is kind of neat. This is not hot. This is several hours. It's been sitting on the counter for several hours. But you can kind of see that as the, is it focusing? Just focus. But you can't hear the sizzle. It makes it, you can see the bubbling though. All right, so that's your copper 2 sulfate pentahydrate. All right, and there's our stuff. All right, so what next? What else can we do with this, with hydrates? All right, so next. All right, so another thing that you can do is, if you don't know the formula, right? Before we knew the number in front of the H2O, we knew the mole ratio of water to the salt, the anhydrous salt. But if you don't know the formula, you can use lab data and figure it out. So I'll walk you through this. What do you need to know? Well, you need to know the mass of the hydrate. The hydrate is the thing with the water in it, right? So that would be, if we're talking about the hydrate, it's the stuff, the original stuff we started with, right? It's got water, it's got some sort of salt, some sort of ionic compound in this case. So what's the mass of the hydrate? What's the mass of the anhydrous salt? That's what's left. That's what's left on the, when you're done heating it. Oh, by the way, that was 46.88. Forgot to write that in there. Okay, so, and then the mass of water. So if you know these two things, you can figure out the formula of that hydrate. All right, so take, for example, aluminum potassium sulfate. We have 2 units of sulfate there. And if I said, okay, we don't know what the mole ratio is of water to the salt, well, we could do a lab and try to figure that out. So this is a sample of lab data. We have 42.05 grams for the evaporating dish. The hydrate is, plus the evaporating dish, is 49.66. The evaporating dish and anhydrous salt is 46.20. Again, you don't want to write grams all the way down. You just write it at the top of the column. Go from there. So the mass of the anhydrous salt, if we take this value and subtract the 42.05, we get let's use a red. We get 4.15. Right? So it's the difference between those two. And we're using the molar mass of aluminum potassium sulfate, you should come up with about 258. So make sure you can come up with that number. All right, let's do the mass of water. Go down here before we start talking about the numbers over there. The mass of water is Well, we have this hydrate. This was the hydrate. This is after we've driven it all off. So the mass of water is this one minus this one. 49.66 minus 46.20. We get 3.46 grams of water. Okay, so we know the mass of the anhydrous salt. We know the mass of the water, but what we want is the mole ratio of these two things. So we need to convert them to moles. So we take our 3.46 grams of water, divide by 18.02, and we get 0.1920 moles of water. For the salt, we divide 4.15 by 258.21. We get 0.01607. So this is our mole ratio, but what we want is a whole number mole ratio. So we divide both of these numbers by this 0.01607 because that's the lower number. That means we're going to have, for every 1 mole of anhydrous salt, right, when we divide the number of moles of water by it, we get 11.95, which is very close to 12. You can see it. So very close to 12. So that means there are 12 moles of water for every 1 mole of anhydrous salt. Therefore, that number right there, it's no longer a question. The number is 12, and it comes from that calculation. All right, so now you should be able to do a calculation like this. Right? So if you had magnesium sulfate and you were trying to figure out what is the mole ratio of magnesium sulfate to water, here's some data you can use. I will note this is lab data. I did this myself earlier today. The water was not completely heated out. I was running a little bit low on time in class. So you should be able to use this data to figure out what number goes there.